So this week 8 quiz is about momentum, and I'm going to do all 5 quizzes. It's really quick. I'll go by numerical order by the sections. So this is section 151, which is my last recitation for some reason. The first one is 152, but that's neither here nor there. Okay, so the x component of the net momentum of the particles. The way this is worded, this really should have said system. But I just typed it as I was given it, and I think this is the way it was in the book. So the x component of the net momentum of the system, if we define the system to consist of A and C. So just these two. And the x component, the momentum of A has no x component, it's just a y component. Because remember, momentum is mass times velocity, where the vector quantity of the momentum comes from the vectorness of the velocity. But the total, or the net momentum, will be just the sum of the vectors, so the momentum of the constituents of the system. So if the system is A and C, then the total momentum will be the momentum of A plus the momentum of C. The momentum of A is the mass of A times the velocity of A. The momentum of C, mass of C times the velocity of C. Now I'll wait to put in the numbers, but let me explicitly write this down. What is the velocity of A? It's the x component of A in the I-hat direction plus the y component of A in the j-hat direction. Similarly for C. So that's the velocity vector written down in component form. Now we can start putting in the numbers. So what actually is the momentum of A? Well, it's the 5 kilograms, and I'll put in the units so you can keep track of these numbers. The velocity component AX is 0. So 0 I-hat plus the velocity component of A in the y direction, that's negative 11 meters per second, j-hat. So the momentum of A doesn't have an x component, it's just negative 55 negative 55.0 kilograms meters per second in the j-hat direction. And then for C, what is the mass of C? That was 10 kilograms. And then that's supposed to be plus 10 kilograms times the x component, that's negative 3 meters per second, I-hat, negative because it's pointing in the negative x direction, and it has no y component, so that's 0. Nothing, the velocity vector doesn't point up or down at all. So this is negative 30.0 kilograms meters per second I-hat. So the total momentum will be negative 30 kilograms meters per second I-hat plus negative 55.0 kilograms meters per second j-hat. But the question's only asking me for the x component. So P total x is just that part, negative 30 kilograms meters per second. So now I'll go ahead and do what was given to section 152. This time they're asking for the y component, and the system just consists of A and C. I guess that was the same as before. In this case though, only A has the y component, C, no y component. So by the way, like you didn't have to do all of this, right? I'm just showing you explicitly what was going on. Here, you could have just said, oh, we're looking for the y component of the net or total momentum, where the system is A and C. Well, I look at C, that's got no y component. Just A has a y component. So I could have just written this down right away. And that negative sign is important because P, the momentum, is actually a vector, so I need to know the right direction. Just out of curiosity, what is the total momentum for the system? It'll be same thing, negative 30 kilograms meters per second, I hat, plus negative 55.0 kilograms meters per second, J hat. Alright, so that's the answer for the y component. That would have been the answer for the x component, like it was up here. Alright, so next section, 154. Find the x component, and the system's B and C. So don't look at that, just those two. And the x component, well, both of them have an x component. So P total x will just be the momentum of B in the x direction plus the momentum of C in the x direction. The momentum of B in the x direction, that's the mass of B, times the velocity of B, x component. And then momentum of C in the x direction, mass of C, times the velocity of C in the x direction, the x component. So that is 6.0 kilograms. And the velocity of B in the x direction will be 10.0 meters per second times cosine 60 degrees. Put the meters per second there. I hat. Well, no, I don't need the I hat. Right, I'm not saying the vector, I'm just saying the component. So no unit vectors are needed there. The mass is 10. The velocity, the x component of C's velocity, is negative 3.0. Right? Because it's going that way, it's pointing that way. What's cosine of 60? Is that 1/2? I think that was 1/2. 60 cosine. I'm not in degrees. 60 cosine, yep. So 6 times 10, that's 60, times 1/2, it's 30 kilograms meters per second, plus, and then that's a negative 30 kilograms meters per second. So this was I think this was the only quiz where I would accept 0 or 0 kilograms meters per second. Like those units, put the units back on at the end. put the right units back on at the end. Okay, so section 251, y component of B and C. Don't look at that. So P total in the y direction is PB in the y direction plus PC in the y direction, which is mass of B, velocity of B in the y direction, plus mass of C, velocity of C in the y direction. MB, I'll call that VB naught. This is VB naught. Oh, wow. Huh. The ink goes under that. Anyway, VB naught is that. So, y, that would be sine 60 degrees plus MC VCY. Well, C's got no y component of velocity, so that's 0. So 6.0 kilograms times 10 times sine of 60 degrees. 60 sine times 60, 51.96 kilograms meters per second. And finally, section 254, the y component of all three objects. Well, doesn't matter for C. C has no y component, but B does and A does. The total momentum will be momentum of A plus the momentum of B plus the momentum of C, but the y component of that is only PAY plus PBY because the y component of C is 0. No y component. Yeah, maybe I shouldn't have drawn that. Just no y component of momentum. So what is that? MA VAY plus MB VBY, 5 kilograms times negative 11.0 meters per second plus 6.0 kilograms times, that was 10 meters per second, times sine of 60. So we have negative 55, I'll leave off the units for a minute, times 60 times sine of 60, or plus 60 times sine of 60, 51.96, so the difference is negative 3.04 kilograms meters per second. There you go.